Yes, hello everyone. My name is Mukwaba, a student of computer science, year 2, Makerere University, and I'm here to take you through my machine learning model that I'm going to use for this project in regards to computer science as a whole and machine learning as a course unit. So let's dive right into it. So we're going to be working with predictive maintenance with machine learning. Here we are going to look at enhancing computer health and reducing downtime. Well, machine learning is a branch of artificial intelligence that empowers systems to learn and improve from experience without explicit programming. So in context to computer maintenance prediction model, which is what we are handling as a group, and me specifically, machine learning plays a vital role in preventing issues in computer systems through predictive maintenance. So we have the different types of machine learning. Um, One, we have supervised learning, where training models with labeled data for predicting specific outcomes. Two, we have unsupervised learning. Here, we discover patterns and anomalies in data without predefined labels. And three, we have reinforcement learning. So reinforcement learning is training models to make decisions based on interactions with the environment. So basically, those are the three types of machine learning that we're going to look at in regards to our machine learning model. So let's dive right into each learning algorithm and how it's going to be applied in our model. Well, we are going to start with supervised learning. So in supervised learning, we have in supervised learning involves training a model on a labeled data set where algorithms learn from known outcomes. Literally, supervised learning uh, data sets where data sets learn from known outcomes. Literally, these are things that move on. Probably with, if it is a computer system, there is a problem that keeps on running and gives an outcome that is not desired. So we are going to use this supervised learning model so that it's able to label data sets where algorithms learn from a known outcome. So in this project, supervised learning is applied to predict computer maintenance needs based on the patterns and characteristics identified in the historical data. So algorithms used shall have decision trees, shall have support vector machines, and the types of problems solved shall have classification here, which is predicting maintenance needs basically. Then shall have regression, which is predicting time until maintenance. So we have labeled data utilization. Our historical maintenance of data sets consisting of labeled instances indicating whether maintenance was needed serves as a foundation for training and validating the supervised learning model. Basically, that's self-explanatory. So we shall go to our next one, which is unsupervised learning. So unsupervised learning deals with data sets that lack explicit labels and predefined outcomes. So basically, in our project, we shall look at unsupervised learning and apply it to discover inherent patterns and anomalies within the computer system data. So, and here we shall use algorithms and techniques of the unsupervised learning as k-means clustering and anomaly detection. So the types of insights we are aiming to discover include clusters of computers with similar usage patterns. Then two is identifying anomalies or outliers that deviate from the norm or from the normal. So how are you going to handle unlabeled data? So we shall handle unlabeled data by allowing the algorithms to autonomously identify patterns and structures with then we can extract meaningful insights from the computer system data without the need for explicit labels associated with maintenance needs. So we shall move on to our next, which is reinforcement learning. So here an agent learns to make decisions by interacting with an environment. That's reinforcement learning basically. So this is integrated in our project by modeling the computer system as an environment, predictive maintenance. The predictive maintenance model as an agent, the reward system based on the effectiveness of the maintenance decision. So I've talked about environment, agent, and reward system, which I'm going to explain. So environment, here the computer system and its operational dynamics serve as our environment, of course. Then the agent predictive, then the agent will be the predictive maintenance model. The reward system is based on the outcomes of the maintenance decisions from the agents, of course. So reinforcement learning in our project addresses decision-making processes related to maintenance actions. The model learns to optimize maintenance schedules, allocate resources effectively, and adapt to solving conditions in the computer's environment. Yeah, basically those are the three learning algorithms of machine learning that we shall use, and that's how they'll be implemented in our model. So we are going to look at the scenarios. But before the scenarios, let's look at comparative analysis. We shall compare all these learning algorithms and look at which is best, basically. So while supervised and unsupervised learning focus on learning from labeled or unlabeled data, reinforcement learning emphasizes learning through interaction with the environment. Basically, in this statement, we try to compare the different machine learning algorithms in regards to supervised, unsupervised, and reinforcement, because supervised and unsupervised look at labeled and unlabeled data to act, whereas reinforcement learning emphasizes learning through interaction with the environment. So therefore, in context to predictive maintenance, which is our project, reinforcement learning allows a model to adapt and learn from the consequences of its own actions, leading to dynamic and adaptive decision making. So in basically reinforcement learning would be the best machine learning algorithm to use. So we shall look at use cases and scenarios in regards to the three different machine learning algorithms. So we have supervised learning scenario, where the scenario is supervised learning is applied to predict whether a computer system will require maintenance within the next month based on historical data. The labeled data sets consists of instances where a computer either needed maintenance or not. So our expected outcome would be the model trained using supervised learning will be able to classify new instances accurately, providing a binary prediction of whether maintenance is needed. We move on to unsupervised learning scenario. So here the scenario is unsupervised learning is utilized to cluster computers based on their operational characteristics, identifying natural groupings within the data. Anomalies are also detected to pinpoint computers exhibiting unusual behavior that may indicate potential maintenance issues. So here I expect outcomes as the clustering analysis helps in categorizing computers with similar usage patterns, allowing targeted maintenance strategies. And our last algorithm is reinforcement learning, but the scenario is employed to optimize the maintenance scheduling process. The model acting as an agent, learning to make decisions on when and how to perform maintenance actions based on feedback from environment, which is a computer system dynamics basically, and the reward system. So the expected outcome would be over time, the reinforcement learning model adapts its decision-making strategies to maximize rewards, resulting in an optimized maintenance schedule. Yeah, so we move on to the challenges and considerations. So we have challenges. We have data quality. So inaccurate data and incomplete data may lead to biased predictions, hindering the model's ability to accurately identify maintenance needs. So the consideration would be over solution. Yeah. Would be implementing thorough data processing or pre-processing steps, including data cleaning and handling missing values, which is crucial. So you have real-time monitoring. In dynamic environments, the need for real-time monitoring of computer systems to compare changes in usage patterns and hardware health metric poses a challenge. Excuse me, I'll redo this. In dynamic environments, the need for real-time monitoring of computer systems to capture changes in usage patterns and hardware health metrics poses as a challenge. So delayed or outdated data may lead to suboptimal maintenance decisions. So the consideration would be implementing a robust real-time monitoring system, possibly incorporating sensors, automated data collection mechanisms, which ensures that the machine learning models receive timely updates. So the other will be adaptability to changing conditions. So here we shall be ensuring that the machine learning models, particularly those using reinforcement learning, adapt to evolving conditions in the computer system environment. So, which is essential for maintaining optimal performance. So here our consideration is going to be regularly retraining models with updated data and incorporating mechanisms for continuous learning. So this will enable the models to adapt to changes in the model. So in conclusion, therefore, in a nutshell, predictive maintenance project, our project basically, which is predictive maintenance, integrates supervised, unsupervised, and reinforcement learning to revolutionize computer management. So the success of our project lies in navigating challenges, maintaining data quality, and upholding ethical consideration, ultimately paving the way for data-driven transformation in the information technology management practices. Thank you so much. I'm glad and grateful for the opportunity to take you through my project. I remain Mukwaba Dennis, student of computer science, year 2, Makerere University. Thank you.